Well, analyzing the function f of x is equal to 2x to the 5/3 minus 5x to the 4/3, we found some intercepts, the domain, and let's see, no horizontal asymptotes. We figured out what its in behavior was supposed to be, and we saw that it has no symmetry. Where did the y go? I don't even know. All right, so next up, we'll do some calculus in order to figure out where it's increasing, where it's decreasing, its relative extrema, its concavity, and any possible points of inflection. So we'll start that process by finding the first derivative. So f, I'm just going to write it down for convenience again. F was equal to 2x to the 5/3 minus 5x to the 4/3. There we go. Except let's make that less like a plus sign and more like a 4 and take its first derivative. Boop. Leapfrog. I have 10/3 x to the, subtract 1 from that, that's like subtracting 3/3, that's going to give us 2/3, minus, and then leapfrog 20/3 x to the 1/3 power. All right, and now I want to know, where is this thing equals 0 or undefined? It's not going to be undefined because we have cube roots and there's nothing in the denominator or anything like that, so everything is fine there, but it could be equal to 0. And in order to tell, let's factor it. See, we can pull out a 10/3 x to the 1/3 power. Okay, and let's see, x to the 2/3 divided by x to the 1/3. Subtract your exponents, you get x to the 1/3. That should make sense because if we were to multiply these together, we would add them together to get that 2/3. And then minus 2. Boop, boop, boop. We're going to set that thing equal to 0. And we can see that we have a critical number at x is equal to 0 from that first factor. And then on the second one here, we have x to the 1/3 minus 2 is equal to 0. Add the 2 over. And then cube both sides, we get 8. All right, we already know that as far as this goes, this is 0, 0, right? Because that was an intercept. How about 8? Let's plug 8 into our function. So we'd have f of 8 is equal to 2 times 8 5/3 minus 5 8 4/3. And I know what you're thinking. You're thinking, oh, I need a calculator for this, which would be helpful, but yeah, I think we can take this one because it is cube roots of 8, which are handy because the cube root of 8 is just a 2 here. In both of these cases, 2 and a 2. You do that part first to make your number smaller. Now 2 to the 5th power is 32. 32 times 2 gives us a 64. Minus 2 to the 4th power is 16. 16 times 5. 16. 5 is 80. 80, which gives us a negative 16. There we go, negative 16. So we've got 8 comma negative 16. Let's plug those. Let's plot those points on our graph grid. Already have 0, 0, and then 8, 5, 6, 7, 8 is right there, and then negative 16. Follow that sucker down to right there. Wow, what do you know about that? We just had exactly enough room. Let me get rid of this little thing. There we go. All right, what could possibly happen at these 2 points? At 0, 0 and 8, negative 16. These are critical points, and this is where our possible min and max points are. To be able to tell, we could just do the first derivative test. Why don't we go ahead and do that? First derivative. Let's pretend that says derivative. I'm good with it if you are. Let's find some intervals. And now these intervals are going to break up all real numbers. Intervals. All real numbers broken up over 0, and then from 0 to 8, and then from 8 to infinity. We need some test values. From negative infinity to 0, I'm actually going to choose -1. That makes sense. And then a 1 here, and then a 27 here. Why did I pick 27? Because it's a perfect cube. That's why. And where do these numbers go? They go into the first derivative, and we just want to be able to see, is it positive or is it negative? Okay, so where is our factored form here? It's right here. Okay, so on the outside, this can be either positive or negative. Likewise, the inside can be positive or negative. We're sticking in a -1. It's going to be negative on the outside, and it's going to be a negative minus 2, still negative. Negative times negative makes this positive, meaning that f of x is increasing on that interval. And then if I stick in a +1, +1 makes this positive number out here. 1, cube root of 1 is 1. 1 minus 2 is a negative number. Positive times negative makes this negative. It's decreasing. And if we're increasing and then we're decreasing, we found ourselves a relative max at 0, 0. If you're going to justify this on the calculus exam free response section, remember you would say something along the lines of, since f prime changes from negative to positive? No, try again. Positive to negative. Yeah, that's sufficient. All right, we got one more, 27. Let's plug our 27 up in there. So 27, cube root of that, that's 3. This is going to be positive. That's also a 3. 3 minus 2 is going to be positive. Positive times positive, it's back to being positive again, which means it's increasing, decreasing, and then increasing. Here we found ourselves a relative min at 8, -16. And again, for justification reasons, since f prime changes from negative to positive. All right, so that ends the first derivative test. We have a relative maximum, we have a relative minimum. What's still left to do is to figure out its concavity and possible points of inflection. I'll save that for the next one.